All right, we're going to jump into section 6.2 here on combined or joint PDFs. Kind of looking at these probability distributions, combining a couple different things, whether we are doing adding or subtracting to a whole distribution, or we're taking two distributions and combining them in some way, shape, or form, or both. All right. So as a little recap, here's an example we looked at. Um, I believe we looked at this one last time. This one says Pete's Jeep Tours offers a popular day trip in a tourist area. Okay. Actually, this is a new one for today. But let's see equal the total amount of money that Pete collects on a randomly selected trip. So here's our um, amounts of collecting and the probability that that happens. Describe the distribution of C. Okay, I would, if I were you, pause and try this one. But what I'd be looking at for this, when we are describing a distribution, we need to know what the distribution is first. So we're going to make a little histogram and look at the shape. And I would say this one is fairly symmetric and somewhat normal looking. Okay, so describing distribution, you're thinking SOC V. Little recap, little review of that. SOC V, something you shouldn't forget. So the shape, I said, the distribution of money collected is fairly symmetric and unimodal. You could also say potentially somewhat normal looking, with a peak at $600. Now, you also need to look for any outliers. I might state no clear outliers. Doesn't look like any at all. But then we got to get into the center and the variability, and that would be things we learned with these probability distributions, the mean and the standard deviation. Now, I have all of that here, and I have the work that goes along with it, and we can then describe that on average, the amount of money collected from these Jeep tours is $562.50, or on average, we would see $163.46 vary by that much from the mean of 562.50. Now, that's how you can find those. We talked about those formulas in the past. I want to just really quickly show you calculator-wise. If you put those things if you go to stat edit and put those into your lists, you can find the mean and standard deviation really quickly on here. All right, so I'm going to quit, get out of here, and I'm going to go to stat calc, one variable stats. Now, in the past, we've only done the list that we've looked at, but this frequency list is basically changing the frequency of each part. So the probability of each thing is a little bit different. So that's our list 2. So I got to put in list 2 there. Now, if I calculate, it gives me those things. Like at the very top, we got $562.50. It doesn't give us the standard deviation of the sample, so it's going to go straight to sigma 163.46. I think that's what we had before, and that's what we needed. So we can use one variable stats with this information. Okay. So now we're going to go back, and let's say we take this situation and we add a little bit to it. Let's say it costs Pete $100 to buy permits, gas, ferry pass for each day trip. So it actually costs him money. Let V be the amount of profit that Pete collects on a randomly selected trip. Now, instead of just the money he brings in, now it's profit. So all that money he brings in, what do we have to do with it to find his daily profit? It would be subtracting 100, which means we'd have to do that to every single individual part, right, to find our new mean. We said with means, when you subtract from all of them, but you also just subtract from the mean. So now, if I wanted to just find the mean of that, it would have just been that 562.50 minus 100. So my new mean is 462.50. That's his average profit after what he has to pay. Standard deviation. Does standard deviation change when you add or subtract? No, it does not. It's still the same spread. Right? It's still 163.46. No change because it's adding or subtracting. Only multiplying affects that. Now, if we actually wanted to compare the two distributions, C was the total collected and V was the profit, it doesn't look a whole lot different. I just kind of put it on here a little bit different, but which makes the bars look a little bit wider. But really, it's the same exact thing. It's worth noting when you're comparing them that same shape just shifted. Obviously, you'd want to compare their means, how the means are $100 different and the standard deviations are the same. But for this, we don't need to change the shape. Still no outliers. So just real quick separate situation, just to add one to it. We're going to come back to that tourist one in a little bit. Say WCTC considers a student to be full-time if he or she has taken between 12 and 18 credits. The number of units X or credits that a randomly selected WCTC full-time student is taking in the fall has the following distribution. So you can see the highest probabilities are at 12 and 15. The least common is 14 and 17, it looks like. So this one says at WCTC the tuition for full-time students is $50 per unit. Find the distribution of T. So how does that change? Well, if you think about it, we can still find the mean and the standard deviation of X. So let's find mean, standard deviation of X. And let's just say we went to our calculator and found that. I'm not going to make you write that all out right now. But I'll give you, it ends up being 14.65 credits. The standard deviation of 2.056. So that is the average and standard deviation of the amount of credits for a full-time student. Now, if we want to find the distribution of T, which is the tuition, that changes a little bit. How do you find the tuition? Based on number of credits. Well, if it's $50 per credit, guess what? Your average tuition is just times 50. Okay? $50 per credit is pretty cheap. Which means we could, in our calculator, take all of list 1 and multiply by 50. Or we can just take our mean and standard deviation and multiply them by 50. The standard deviation also will multiply by 50 because it is impacted by multiplication. Which means our mean, our new mean for a tuition would be $732.50. Standard deviation also gets multiplied. It's a spread of 102.80. So hopefully that helped see the difference between adding and multiplying. So as a quick recap, when we are adding or multiplying for any random variable, with any random variable, the mean is just the mean, the standard deviation is just the standard deviation. But when we're adding, it does impact the mean. It does not impact the variability of the standard deviation. We're going to put that here. And another recall from last time, when you're multiplying, you do have to multiply both. This is important to note that this only works for a positive standard deviation. We can't have negative spread, negative standard deviation. So that's why we do the absolute value there. So you might be given something like this. Say, given independent random variables with means and standard deviations as shown, find the mean and standard deviation of these variables. So I've got A and B here. So let's take our X. Let's say our X has a mean of 10, our standard deviation has a our standard deviation of 2. 3X, for 3X, I would take my mean, I'm going to make it mean of 3X, and I really am just going to multiply the mean by 3. So it's got to be 3 times 10, or 30. All right? The standard deviation, though, is also multiplied. So we can take that 3 times 2, I get a standard deviation of 6. Okay? So multiplying impacts both. In this second example, let's just say we're taking 6 minus 2y. So the random variable y has a mean of 20 and a standard deviation of 5. So for that one, we have to look. There is multiplication and there is addition or subtraction. We've got both things here. And if there's both things, we are only going to look at it depending on which thing we're looking at. So the mean, which would be the mean of 6 minus 2y, does get impacted by both. So I would say 6 minus 2 times 20, and I get a mean of negative 34. But standard deviation of the 6 minus 2y is only impacted by the multiplication. So we don't actually deal with that 6 at all. It's just negative 2, which I'm going to put in absolute value bars, times y, which is 5 times the standard deviation of 5. So it ends up being a spread of 10. Okay? So that's the difference there, whether we're looking at multiplication or addition, multiplication versus addition. Okay? Now, something else we've learned, and we're going to come back to now and use this, is what if we're combining, so same situation, what if we're taking a look at two different distributions and combining those, not just multiplying or adding in numbers at a constant, we're actually combining the distributions. So, example C, so what if we do x plus y? What's the mean and what's the standard deviation? Okay, so let's do a quick recall. All right, mean of x plus y would be adding x plus y. Maybe 10 plus 20, the means, and I get 30. But standard deviation is not that. We have a special formula for that. Do you guys remember what it is when we're combining distributions? And it's the same no matter if we're adding or subtracting. It is the square root, in this case, of each of their variances added together. So that's the square root of 4 plus 25, which is 29. I'm going to leave it like that for right now. You could simplify that if you wanted. I'm just going to leave it as the square root of 29. It is approximately like 5.4-ish. All right, so recall there, if we are adding two distributions, add the means, take the square root of the variances, add it up. Subtracting is similar. We're subtracting the means, but this is also the same standard deviation. And I'm going to make a big note. This is only if we know they're independent. We can't do this if they're not independent events, because then, like, probabilities change. It's not going to all work out to be the same. So let's go back. If we did x minus y here, we would find the mean to be 10 minus 20, which is negative 10. Standard deviation, however, is still the square root of 2 squared plus 5 squared, which is the square root of 29, or about 5.4 again. That did not change. Last example here, if you're going to do two of the same thing, so that'll change. It's not going to be the same as before, but we are adding. It's going to be the mean of 10 plus 10, so we get 20. So this one has a mean of 20, whereas the standard deviation is going to be the square root of 2 squared plus 2 squared, which will get you the square root of 8, or about 2.9-ish. Okay? So we're going to utilize both of those things now with this last example. Actually, it's the same example. Let's go back to this. Back to this Pete's Jeep Tours. We're just going to look at some different things with Pete's Jeep Tours. So let's say X is the number of passengers on a randomly selected trip. Okay? So here's the chances of 2, 3, 4, 5, or 6 passengers. We're going to say Y is the number of passengers on a randomly selected trip on Aaron's. So Aaron also runs Jeep Tours in another part of the country. She happens to be Pete's sister. They do the same thing, just in different parts of the country. She can only take 2, 3, or 4 people, and here are your distribution of the number of passengers. What I'd like you to do is, real quick, pause, find the mean and the standard deviation of X, find the mean and the standard deviation of Y. If you want to use E for Aaron and P for Pete, you can do that as well, but this is what the X and the Y are. All right, hopefully you had a little more practice with your calculator using one variable stats, the list 1s and the list 2. I've got the means and the standard deviations for each one here, and we're going to utilize those now. Okay? So let's say, same deal here. Find and interpret the mean and standard deviation of the sum. So S is going to be X plus Y of the number of passengers Pete and Aaron will have on their tours on a randomly selected day. Okay? So we want the, for S, we want the mean and the standard deviation if S is equal to X plus Y. Now, back to what we talked about, this is just adding two different distributions. So if we have these mean and standard deviations that we just dealt with, we're going to take those and we're just going to add for the mean. So the mean of X plus Y is the mean of X plus the mean of Y, right? So go ahead and find that. That's 3.75 plus 3.1, and you get 6.85 passengers in total on average. Okay, I would say make sure you have an explanation where we'd expect 6.8 passengers on, or 8.5 passengers on average between the two of them on any given day. Okay, standard deviation you can also add in there. It would be the square root of their two variances, so 1.09 squared plus 0.94 squared. And I got about 1.439. So same deal. That's the standard deviation. We'd expect there to be 1.34, to vary by 1.439 passengers from the mean of 6.85 on any given day. There's our explanation. Let's make it a little more difficult. Maybe not, maybe a little bit. But let's just say, same deal, find and interpret the mean and the standard deviation of the difference. So D is going to be the difference between the two. So how much different is it going to be on average? So why don't you go ahead and try those. So feel free to pause it if you'd like. But I would be subtracting for the means. And you get an average of 0.65 passengers difference. And on average, that might vary by whatever I get here. So same deal. I don't even have to do anything different. It's going to be all the same. I would get still 1.09 squared plus 0.94 squared. I get 1.439. Well, let's make it a little bit more difficult here. Question C with the same situation says it costs $20 plus $5 for each passenger for insurance. That's for Pete. And for Aaron, it costs $15 plus $7 per passenger for insurance. Find the expected total they spend together on insurance on a randomly selected day. So they have to insure this thing. And then we talked about how they get a certain amount of money per person or whatever. But say it costs them this much to insure. What is the mean and the standard deviation on all of their money together? Okay? So, this is a little bit more. So let's take Pete's. Let's just say his is 20 plus 5x. Or I could do capital X because I'm dealing with every, depending on the thing. For Aaron's, it is 15 plus 7y. We want to know a total cost adding them all together. Okay? So ultimately, we have to do a little bit of work with each. And we got to think about the adding versus the multiplying. So for our mean of x plus y, in this case, we have to take both of those. So essentially, we are plugging in, because mean is affected by both, we're going to take 20 plus 5 times the x, which was 3.75. Okay? That's Pete's. We want to know a total. So adding in Aaron's cost, it'd be 15 plus 7 times 3.1. That's the average. And I will get a total cost between the two of $75.45 per trip. That is my mean. Okay? Now with standard deviation, we have to think a little bit more. Because standard deviation is not impacted by the adding. And we are using two different distributions, so we're still using this formula. So for Pete's, it would be 5 times the standard deviation of 1.09. We don't have to add that 20 because it's not impacted by adding. That doesn't change the spread. So it's that squared. For Aaron's, it's going to be 7 times 0.94, and that's going to be squared. And if I add those up, take the square root of that, I will get my standard deviation, which I got to be $8.54. Okay. Now, all of this is possible because we know how to do it, because of what we learned, and one big assumption. What assumption is this? And I mentioned it a couple times, but it is really important to note. We are assuming that x and y are independent. I'm assuming that they're things like being across the country, they're not impacted. So I'm just going to say, like, if I wanted to explain that, knowing number of Pete's passengers has no impact on the number of Aaron's passengers. Just because there's so many people in the world and they're in different parts of the country, it probably has no impact. Very important. All right. Now, we'll kind of recap this next time, but all those things go into what we're learning today about combined or joint PDFs. We need to be able to put it all together. All right. And that is section 6.2. We'll see you next time.